thing I noticed in your homework was that they gave you a few Ferris wheel problems, and they gave you some daylight type problems or tidal problems. Now, all of those, section 6.1 is very long, and they give you oodles of problems like that. So you can expect to see something like that on your test next Monday. I will pick one of those types of problems, either like a daylight problem or a tide problem or a Ferris wheel problem. That's a guarantee. One of those will be on your tests. So make sure you can work through those, okay? And if not, that's when you can come see me, go to the studio, or talk to some of your classmates. Okay, and I keep seeing phones coming in and out of pockets, and I don't want to embarrass anybody, so I would like to ask you to please stop doing that. All right, so let's talk about this. Would anybody be willing to share with me? I mean, I'm thinking that there's probably several ways you start to look at these, like how you start to look at these to come up with the equation for this particular function. Boy, quietest I've ever heard the class. You go after the amplitude. And how do you decide what the amplitude is? What do you have to find? Yeah. So when you say you find the highest and the lowest point, and then you find the midline, right? Because you really need to know what the midline is before you can really determine what you could try to guess, right? But it's really good to know what your midline is. That's a great way as a starting point. But do you look at the graph and decide where does the graph begin? I mean, that's kind of a question that nobody really knows the truth about, since it goes on forever and ever in both directions. So we usually say, look at your y-axis and look for your y-intercept, right? So your y-intercept would be right here at 0,60. So you're starting at the high point of the hump, right, which we call mathematically your max, and you're going down, you're crossing your midline, and then you get halfway through and you're at your low point, the bottom of the hump, and then you come back to the top of the hump. That's the characteristic of a cosine function. So first I try to decide, do I have a straightforward sine, opposite of sine, cosine, opposite of cosine, without any shifts going on, because those are much easier. The midline, or another word for midline, is the central axis, right? That's what we used to call in rational functions the horizontal asymptote, right? But it's not the same thing here. So midline is where you want to start, and at least that's where I start. Again, I first try to identify which of my four basic functions do I have, which is what we have right here at the beginning of our lesson today. If I can get there. Right here. Here's the beginning of our lesson today. So you've got these four basic sinusoidal graphs. Notice the term sinusoidal applies to both cosine and sine because they're essentially the same graph. Cosine is just a little bit ahead of sine, right? Sine takes to pi over 2 to get up to 1, whereas cosine starts right out at the highest point, 1. So the cosine graph is just the sine graph shifted to the left. Pi over 2, that's all it is. So they're the same graph. And so we're going to talk a little bit about the features of these in a minute. So that's probably not a bad idea is to see if you can identify, is it sine or is it cosine? Now, someone could argue, did I go too far? Yeah. Someone could argue, well, wait a minute. I could look at that graph and say it's a sine function too, and you can. But then you're talking about shifting. So there's infinite many equations you can get because everything's periodic. You could add 2 pi to it. You could add any multiple of 2 pi, and you would be right. So we're just going to try to be nice and easy here. We're going to say our high point is 60. Our low point is what? 10. So to get my midline, I'm halfway, so that's the average between my high and my low. So my midline is going to be at 35. Okay, so that's where I start. And as Kyle mentioned. You take your high, your low, you go halfway in between. And remember, your midline is always an equation. If you just write 35 down, points off. It's always an equation. So, okay, 35 is going to be right about here, midway through. It's also the radius, if you're thinking about it, right? Like the Ferris wheel. All right. And from here, you can say, okay, my amplitude is just the distance from my midpoint, my midline, my central axis from 35 to 60, or from 35 to my low point, 10. In both cases, it's 25. So my amplitude is 25. So I know my function's going to have this form. Now notice our book uses H and K right here. H and K. Very similar to when you were studying quadratic functions. And you had x minus h quantity square plus k. Some books use a big capital C here and a big capital D here, or vice versa. But your book uses this notation, so we'll stick with that. All right, so we've already identified the amplitude right here is as 25. We've already identified our midline, which is just our vertical shift, because regular old parent function for cosine and sine has the y-axis. Now we're shifted up to 35. So this becomes your 35. Okay, we're almost home. All right. Do we have any shift? No, cosine starts right up at the top. So h is 0. So I'm just going to take that all away. Now all I have is b times x, whatever b is. We just got to determine b. All right. So we look between any point on our cycle to its end point. I always like, if I can, to use the peaks because those are easily identifiable. So I begin at 0, 60, and I end at, or begin my new cycle, however you want to think about it, 260. So my period is 2. But that's not what I put here, right? B is 2 pi over the period. So you've got two things going on. The period can be gotten if you see an equation and you see the value of b is 2 pi over b, or b is 2 pi over p. So if you have a graph, you use this because you can determine p, and that will give you b. If I give you the equation and I tell you to graph it, you have to determine the period. So you put b into this formula, and then you know what the period is. So, okay, so we got 2 pi over p. P is what? Do we say 2? So that means our period is pi. Our value for b is pi. So you erase this, and you have pi. And there's your equation. You're all done. Okay? That's it. So today what we're going to look at is this is what we got to on Friday before vacation. We didn't look at what happens with the horizontal shifts, which was the h value in here. So let's take a look at that now. Okay, so with our basic sinusoidal functions, let's talk a little bit about sine. Okay, sine has, if you're thinking about graphing any sine function, you know that the sine function begins, if we are going to, every time I say begins, we're talking about now where the vertical axis, your y-axis, crosses your midline, right? Which we're going to call the y-intercept 0, 0. So your sine function has 3 x or t intercepts, right? And it has 1 hump, 1 max, and 1 min. Always. This particular one has no transformation, so it's between -1 and 1 with our midline at y equals 0. Excuse me. Okay, now when you're trying to find these 1, 2, 3, 4, 5 important points right here, there's 5 kind of key points for graphing. Your 3x intercepts, your x or t value where your max, excuse me, I've got sneezes here coming. Whew. and your minimum point. How do you determine that? Take your period and divide it by 4, which is pi over 2. So that means you start at 0. Your next important point for sine will occur at pi over 2. Here's pi over 2. That's halfway between 0 and pi. And that will be pi over 2, 1. We know that the sine of pi over 2 is 1. Then our next important point will happen pi over 2 away from pi over 2, which is pi. There it is. That's your next time you're at 0. And then pi plus another pi over 2 gives you 3 pi over 2. And that's where your minimum occurs, at 3 pi over 2. And 3 pi over 2 plus pi over 2 brings you right back to 2 pi, and you're back to 0. So when you're trying to think about graphing some type of sine graph, you want to determine your period, divide it by 4, find your starting point, and add each of those increments, those quarters of your period, and then you can graph your whole function. So when it's regular sine, you start at the middle and you go up. When it's the opposite of sine, you start at the middle and you go down, and everything else is the same. Here's pi over 2, that's 1/4 of 2 pi. Here's pi, here's 3 pi over 2, but now you're at your max, and you're back to 2 pi. Okay, you still have your 3 x-intercepts, or t-intercepts. Oh, these are x here. Okay, so that's kind of sine. Cosine, on the other hand, same idea. You have 2 pi. You divide 2 pi by 4, and you're going to get little steps of pi over 2, but now you start at the top of the hump and go down to pi over 2 where you have your x-intercept. Then another pi over 2 at pi, you're at your min. 3 pi over 2, you're back to your midline, and then you end with your max. Okay, so cosine functions start at the top and go down like a roller coaster. Okay. If you notice that you have a function that's starting at its minimum value, that's going to be this thing reflected over your x-axis. That's what negative cosine of x means. So if you start at the minimum value and go up, then that's your negative cosine. Okay. So let's take a look at some new problems today. So today's lesson, we're going to relax this assumption, and we're going to allow all of our sinal curves to start anywhere, not at along the y-axis. They can start anywhere along that x or t axis. So let's do a brief review, real brief, of horizontal shifts. So what would happen to our parent function y equals x squared if g of x, let's call this f, if g of x was x minus 5 quantity squared? What would g look like in comparison to f? What's the transformation here? Yep, Hazel? Yeah, it's going to just, this tells you you move right, you shift right 5 units. So that means the 0, 0 is my vertex on my original function. Now it's going to be 5, 0. Right. Okay. And you can see if you put a 5 in here and subtract 5, you're back to 0. So it's all about keeping the same y values. So to keep the same y value of 0, since I'm subtracting 5, my x has to be 5 bigger than it was on my parent function. What about this one, x plus 3? What's going to happen there to my f function to get h? What would I do? Shift it to the left 3 units, right? Shift left 3 units. So this one would look like this. Negative 3, 0. Okay. So that's all the stuff we did in 107, or college algebra. And we're going to use the same exact idea today. It's not anything new. It's just that now we're graphing sinusoidal functions instead of parabolas or square roots or cubics or lines. Okay. So let's take a look at this. So when I'm first starting something like this, I always draw the original parent function, just so I can get an idea of what's going on. So I would start by just graphing sine of t, and you're going to be able to do sine of t in your sleep pretty soon. You know, sine of t or sine of x has a period of 2 pi. Midway between 0 and 2 pi, you have your other intercept, your t-intercept. Okay, so there's t, and here's y. You know, halfway between 0 and pi, you reach a max. And halfway between pi and 2 pi, which is 3 pi over 2, you reach a minimum. So here's just one cycle of sine of t. Okay? One little cycle. So that's where I like to start when I'm doing a transformation, till I feel really comfortable. So this particular transformation has the same exact amplitude, the same exact midline, because over here you could have a plus 0. So your midline is the x-axis. The only thing different about the same period, 2 pi, the only difference is it's just what? How do I get this function from that purple function? What do I do to it? Yeah, I just move my purple sine curve to the right, pi over 4 units. That's it. So this is a shift to the right, pi over 4 units. Inconveniently, my axis here is divided up into pi over 4 units, right? Each line here is pi over 4. So 0 now is going to move one spot to the right and become pi over 4. Now, you can either say my next point is pi over 2 away and add pi over 2 to this, or you can just keep shifting these points. 1 unit to the right, 1 unit to the right, 1 unit to the right, 1 unit to the right. So here you have sine of t minus pi over 4. So this is y equals, this is just one cycle of it. We know this continues in both directions. This is sine of t minus pi over 4, and the purple one is y equals sine of t. Okay, any questions on that? Okay, again, you could have said you know how we used to do this in 107? We would have 0, 0. We would start with like some key points on our graphs. So we have 0, 0. We have pi over 2, 1. We have pi 0, 3 pi over 2, negative 1, and 2 pi, we're back to 0. This is on our sine function, right? So this would be t comma sine of t. And then we would use our little arrows and we'd say, okay, we're just shifting this pi over 4 units. It's going to be t plus pi over 4. All your y's stay exactly the same. So that was an exercise you did, a lot of you did, with your, when we had functions that were piecewise. So this is 2 pi over 4. When you add pi over 4 to it, you get 3 pi over 4. 1. So you could also do that, and this is 4 pi over 4, so you get 5 pi over 4. So you could just do this sort of thing to get each of your new values on your graph, or you could just visually shift them, whatever works for you. Okay, any questions on this one? All right, so let's take a look at this one. All right, now this is a little tricky because if you recall, let's go back here to our previous little blurby right here, transformations of sine and cosine. And back in 107, I said, you're really going to be happy that we have this form for transformations when you come to calculus. Oh, that's not what I was looking for. Oh, sorry. I guess I haven't put it in yet. So this was just before we had our horizontal shifts. Okay, so let me give you now with horizontal shifts. Okay, so let's put a blank page. So now all your functions are going to have some form, like I just showed you a minute ago, sine of b times x minus h plus k, or y equals a times cosine of b times x minus h plus k. So now we've just expanded what you saw in your previous lesson so that it has a horizontal shift. But the big, really big idea here is that this is always in factored form, always in factored form. So remember in 107, we always did our shape changes first and our shifts second. B is changing the shape because that changes the period. That talks about your horizontal stretching or compression. A changes the shape by either flipping it over the x-axis if A is negative, or being like a regular parent function if A is positive. So this, before you start graphing any equation, you have to factor your input. This is called the argument. You have to factor your argument. Okay, so let's go back to this equation, if I can find it. So right away, it would be really nice if we thought that this function was just 2 pi, sine of 2t, and then shifting it, but it isn't. It's not shifting it pi over 2 units because it's not factored. So anytime you see just adding and subtracting in here with no multiplication, you've got to like have all kinds of bells go off, factor, factor, factor. So the factoring here is to pull the 2. You want to make the coefficient of t be 1. So you divide this by 2. 2t divided by 2 gives you t. And pi over 2 divided by 2 is the same as pi over 2 times 1/2, which is pi over 4. So to get your second term here, inside the parentheses, you divide whatever's there by the number you pull out. That's how you get this. This is arithmetic, folks, so hopefully you're okay with that. Pi divided by 2, divided by 2 again, is pi over 4. Okay. Now this is what you're going to graph. Okay. Notice I tried to keep it so we didn't have to do too much work. It looks a lot like this one up here, right? The only difference is our period is changed. So here our value of b is 2. Here's 2. So now we know that we've got a new period. So we know the period can be gotten by taking 2 pi and dividing it by b, which is this coefficient right here. Here's b. So 2 pi over 2 is pi. So this is going to look a lot like this one, except for it's going to happen twice as fast. It's going to be compressed. And that was always the part that screwed us up in 107. Because we keep seeing that too and we wanted to stretch it, but it's going to happen twice as fast. It's going to happen in half the time or half the length of this axis. So now you say, okay, sine, find the period. My period goes from 0 to pi. Halfway through, what do I have halfway through at sine? Think about going halfway around the circle. You're back to what value for sine? Your y value? Go halfway around the circle. You're back to what value for sine? 0, the y value. Sine is y value. Okay? And then midway between your zeros, you got pi over 2 and pi over 3 pi over 2. You're going to reach, I'm just drawing sine right now. Going to reach your max and your min. Okay, so here's my sine function. Draw a nice sine function. So there's my sine function, one cycle of my sine function. And now I want to graph this one. I'll graph this one in green. So my period now is just pi. So now I say I go from 0 to pi. I want to take pi and divide it into 4 equal parts, pi over 4. So my starting point is 0. I add pi over 4. That's right here. This pi over 4. I come up to my max, which is still at 1. My amplitude hasn't changed. Now I take pi over 4 and I add another pi over 4. That's 2 pi over 4 or pi over 2. So at pi over 2, I'm back down to my midline. Pi over 2 plus pi over 4 is 3 pi over 4, which is 3 pi over 2. Where am I? I went up to the top of my hump. I came back to my midline. And where do I go now? for sine? 3 pi over 2? Look at your purple one. You started at 0, you went up to your max, you came back to 0, and then you went down to your min, right? So come down to my min at 3 pi over 0. And then 3 pi over 2 plus pi, did I say 3 pi over 0? 3 pi over 2, I meant 3 pi, another pi over 4, you're at 2 pi. And you're right back to where you started. So it looks very similar, except for your period is different. Okay. Any questions on that? What about the shift? Am I done? Am I done? What did I just graph? Sine of 2t, that's all I've done, right? So now you do your shape change first, and then you do your shift. So let's do a new color, red. So each one of these move 1 point to the right, 1 line to the right, which is pi over 4, right? So here we got this, we got this, got this, we got this, and we got that. So I've just shifted pi over 4 to the right. There's that equation. So you could do it in all those pieces if you wanted, okay? But you do your shape change first. You got to get your period. Is that right? Well, let's see. We start at pi over 4. We end at 5 pi over 4. That's pi. Your period is pi. So you could have just started there and then made your 4 marks and put your height, your bottom, and your intercepts. Hazel? Well, you won't be able, you won't have any graphing type of calculator. Well, look, so I just want to, let's talk about, can we talk about the test on our review day? But I can also come back here in a minute. I just want to make sure everybody has this. If I would do, it just depends on how comfortable you are. Now, some of you have had this stuff before, so it's not new. Some of you had a little bit of this before and you really need to like review, and some of you have never seen it. So I started with, you know, my parent function and then doing it in pieces. If I were doing this, I'd say, okay, I know my period is pi, so I would, and I'm going to shift to the right to 1 pi over 4. So I would say, okay, here's pi over 4. If I add pi to pi over 4, this is 1 pi over 4. Pi is 4 pi over 4, so I'd go to 5 pi over 4. And then I would divide that up into 4 equal pieces, right? And then I would just do my high and my low and my middle one. I mean, you know, this is like, but you may not be there. Now, what kind of work? Well, I would love to see what the period is and what the amplitude is and what your midline is and your shift. I would write that out. I would say, okay, my amplitude, my midline, my period, and my shift. I would write that out somewhere on my paper so that if you messed up at all, I could see at least you could find those pieces. If you want to rely on just the graph to do it all, depends on what I ask you as well. I may say, find your amplitude, midline, all that, and you'd have to fill it in, which probably I will ask you. Right? But the amount of work should be sufficient so that if you make a little mistake and this is worth 6 points, you don't lose 6 points. I hate doing that. I'd rather just take off 1 or 2, you know, if you have everything else okay. All right, so let's take a look at some more interesting problems. Here's a really interesting one. We got some more interesting ones here to do. Now this one has the whole shebang in it, right? We've got an amplitude change, we've got a period change, we've got a vertical shift down and a shift to the left. We've got the whole thing going on here. All right, so again, where do I start? First, I start with determining what my period is and what kind of function I have. This is a sine function. So I know I'm going to start on my midline. A quarter of the way through, I'm going to reach my max. Halfway through, I'll come back to my midline. 3/4 of the way through, I got my min. And then I have the end of my period back at 0. So that's, I first kind of envision my sine function. I sort of, so like at the top, I kind of have one of these things visualized. And it's not a bad idea just to throw a sine function in. Say, okay, I know this is 0. This is a quarter of the way through, pi over 2. This is pi, 3 pi over 2, and 2 pi. So that's not a bad thing to just have on the side. Okay, so let's determine what our period is here. We know B, here's B. B is pi. So our period is 2 pi divided by B, which is 2 pi divided by 2 pi, which is 2. So that means this entire, one cycle of this entire function is going to happen between 0 and 2. Now from here I find my quarter points. So I say, okay, I'm going to take my period, 2, and divide it by 4. So that's a half. So that means I have something important happening at each increment of a half. So I know I've got something important happening here, 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 and then I'm back to the beginning. Okay. Now, right now I'm marking these points 0 and 2 as if that were my midline. So I'm just going to put just ticks there, little tick marks. All right. My midline is important to know because that's, I have to know that in order to get my high point and my low point. So I'm going opposite of what Kyle said, right? I'm going to find my midline here is now -2. So down here at -2, I just kind of draw this horizontal line. That's dashed, and I put y equals -2, and I remind myself that's my midline or my central axis. Everything is going to start here and go above it and below it, max and min. All right. Now my amplitude is the absolute value of this number. So the absolute value of 5 is 5. So that means my high point is going to be 5 above -2. And my low point is 5 below -2. So let's do that. My high point is 5 above -2, which gives me to 3. That's my amplitude. Y equals 3. And then I subtract 5 from -2, which brings me down to -7. Okay, so that's where my minimum value will occur at -7 for my sine, and my maximum value is going to occur at 3. So what do I still need to do? I got my midline, got my amplitude, I got my period. Do I need anything else? I know my max and min is going to, my max will be at 3, my min will be at -7. I know my midline, which is from here. What shift didn't I do? Horizontal shift. So what's the shift look like? 1 unit left. Okay, right here, 1 unit to the left. Left, 1 unit. All right. So what does that mean? It means sine says I always start at my midline. My midline is down here. And this tells me I'm going to start 1 unit to the left of 0. So guess what? There's a formula for that. Here's h right here, right? H is +1. So where do you start? You start at -h, comma, k. H is 1. The opposite of 1 is -1. K is my midline, -2. There's my starting point. 1 unit to the left, down to my midline, -2. So here's my starting point right there. Let's put this in blue. -1, comma, -2. Okay. So what did I say all my important points would be? In steps of 1/2 to the right, right? Steps of 1/2. So I go to the left 1/2, I'm right here. And with my sine function, that's a quarter of my way through. I'm going to be at my maximum value right up here. I take another step and I come back to my midline. Here we go. I take another step 1/2 to the right, and now I'm at my minimum point, which is way down here, -7. And then when I take 1/2, I'm right back to the start, because from -1 to 1 is a period of 2. So here's my graph. Oops, kind of missed that one a little bit. Okay. And then you can start this whole process again on both sides by all these half steps. Okay. So taking your period and dividing it by 4 really kind of helps you key in on where your maxes and mins are going to be located and your intercepts. Okay. So I'm going to leave this here and see if you can fathom any questions you might have for anything on here. Anything you might have. Yep, Hannah? What are the 2 zeros? Oh, yes, thank you. We were so focused on the axis, yes. Here and here. Where's the other one? Right here. Yep. Thank you. I appreciate it. Yep. So it comes down here through there. Let's get a better drawing here. Yep. It's got to be on your midline. It's an easy mistake to make. I just did it. There you go. Start, max, middle, min, back to the starting point. All signs are done that way. Any questions? Can we move on? All right. What do I got to do to this thing? Got to factor it. 3 times the sine of pi over 4 times t minus, you fill in the blank. And when your table agrees what that question mark is, put up your sign, your flag. Am I still recording? I hope so. Okay. So our period is 2 pi divided by pi over 4, which is the same as 2 pi times the reciprocal. So our period is 8. So I find all my quarter points by taking my period and dividing it by 4. So that means every 2 spaces on my t-axis is going to be where some key point happens, max, min, or an intercept. Okay, my amplitude is 3. My midline is what? 0. Y equals 0, because there's nothing out here. There's just a 0 out there. And it shifts to the right 1 unit. Okay. So I actually know where this function's going to be trapped. It's going to be trapped between +3 and -3, because that's what my amplitude is. So my whole function's going to be trapped right in there. Instead of starting at 0, I'm going to start at 1. And every shift of 2 units to the right is going to be something important happening. I don't want this to look like their intercepts. So let me just say, I know something important is going to happen at 1, 3, 5, 7, and 9. Okay. So since this is sine, I know I start at the midline. I go up to my maximum at 3. I come back to my midline. At 7, I go back down to my min, and then back at 9. There's a period of 8. Whee! There we go. And this goes forever and ever. The next one is more interesting, because we're going to see how you can get 3 different equations, functions for the same graph. and then you'll have a lot of time to play. All right, so again, this is the same idea again. If we're given a graph and we're asked to find an equation, we need to know whether it's if the sine is more appropriate or the cosine, or vice versa. So if it starts at the top and goes down, we know it's a cosine with your amplitude positive. If it starts at its minimum value and moves up, it's a cosine with a negative amplitude. If it starts at the midline and goes uphill, it's sine with a positive amplitude. If it starts at the midline and goes down to the min, it's sine with a negative amplitude. So let's talk about this in this next problem. So want to read this for me? I'm kind of tired of hearing my own voice. Nicholas, want to read that for us? You can say pass if you're not comfortable. Sinusoidal. It's fun to say it. Say it. Sinusoidal. Yeah. Sinusoidal. Yeah. Sinusoidal. Yeah. Okay, so we're going to find one, and then we're going to find two more. Now, how much fun is that? Right? Isn't it fun? All right. Where do I begin? So, you see something like this, and I don't know, do you get like little butterflies in your stomach, or it's scary? I think it's scary the first time you see something like this. I don't know. But so let's see. Where do I start? I noticed that there's a 20-foot difference between low tide and high tide, right? So my low tide is going to be my min, right? And 20 feet is going to be from that low point is going to be my high tide, and then I figure out my midline. So that's kind of where I begin thinking in terms of where is this function going to be trapped between the high and the low. So at 40, I just kind of do one of these kind of things, boom, 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 all the way across. That's going to be my low tide mark, y equals 40. And then a 20-foot difference between low and high tide. And if you're at the Bay of Fundy, it's a lot more than that. Bay of Fundy is up in like New Brunswick area. Y equals 60. So midway between 60 and 40, I have my midline. Here's my midline, y equals 50. So somehow beginning with that midline and the highs and the lows is a very important beginning place. That's where I always begin. All right, it says sinusoidal. This could be a sine graph, it could be a cosine graph. I don't know yet, but somehow I know something if that, what does it say? Does it tell me anything about how I define what my time is? Nope. It just says the low tide occurs at 2 a.m. So I've defined this to be number of hours after midnight. So my y-axis here is my t value here is 0. It's going to be wherever my tide is at midnight. I don't know anything about that, but I do know something that 2 hours later at 2 a.m., I'm at my low point, right? Yes? Okay. So 2 hours later, I'm at low tide, 2:40. What's going to be my t value when I reach my high tide, which is 60 feet? What's going to be my t value? 14 hours after midnight or 12 hours after 2 a.m., right? So I go over here to 14 and I go up to my high. Let's see if I can find 14 here. That's this one. All right. So 14 comma 60. What's midway between 2 and 14? What number is midway between 2 and 14? 8, because 2 to 14 is 12 units. Half of 12 is 6. So that means every quarter of the way through, I'm going to have something important happen. So that means at 8, I'm going to be at my midline, right here. Because I added 6 to 2 or subtracted 6 from 14. So now I do 14 plus 6, I come out to 20. And I'm going to be right back to my midline. Oops, it's right here. And another 6 hours or 24 hours after 2 hours after midnight, which is 2 a.m. the next day, I'll be back down to my minimum. Okay. So I would start this function. Since it's starting at a low point, it's going to come up. Like that. Yep. No, bell curve's a different function. This is not a bell curve. Is it? Kind of looks like one. Bell curves. Are bell curves cosines or sine functions? Has anybody looked up how to graph a bell curve? It's actually from statistics, Jackson. You can look up the normal curve in statistics, and it has an E in the denominator and some interesting, the exponent has mu in it and sigma, but it is not a sine or a cosine. You have to know what the mean and the standard deviation is of the population. But look it up. You can find it. Okay. So now, how would we find a graph for this? Well, it depends on where you want to start. That's the whole exciting thing. If you say this is your starting point, let's call that start number 1, because we've got to come up with 3 functions. So if we start here, we're starting at a minimum and going up to our max. That's negative cosine. Yeah? So we have to know all of these things. A times cosine of B times X minus H plus K. All right. So this is negative cosine. What is our amplitude? Well, from 50 to 40 is 10, 50 to 60 is 10, but it's negative 10 because I'm starting at my minimum point. Okay, that's where I would start. Or my midline is 50. That's my value for K right here. So K is going to be 50. To go from low tide to high tide and back to low takes how many hours? 24. That's my period. My period is 24 hours. So I use that information to find my value for B. So B equals 2 pi divided by my period, which is 2 pi divided by 24, which is pi over 2. 12. Pi over 12. Erase that B and put a pi over 12 there. And I shifted 2 units to the right. So that's minus 2. So there's equation number 1. Yep.
Why is it a negative?
It is. Because you're starting at your minimum value. Right here. Let's take a look. Where did I put that picture? Where is it? Right here. When you start at your minimum point, it's just been shifted to the right 2 units. Your A value is cosine because you're starting at your min and you're going up to your max. Cosine starts at max and goes down to the min. Okay. All right. Given that we have that confusion, where could we start so we had 10 times the cosine and not negative 10? What point could we start at? Hazel? Yeah, suppose we decided, hey, I want to start right there instead. Starting point number 2. Now I'm starting at my max, going through my midline and coming down, and this would continue. So now we could say everything's the same, the period's the same, your midline's the same. What changes here is your value for A is going to be positive 10 if you start there. And you shift. How far did you shift? You shifted to the right from t equals 0 all the way to 14. So it's x minus 14 plus 50. Is it supposed to be x or t? What do I have here? I guess I've defined it to be x. So that's equation number 2. Ooh. Now one more, and then you can start your lesson activities. Start at the midline. How about if I started right here or right here, then I would have a sine function. This one would be negative. This one would be positive in terms of amplitude. So you could fill the last one in later, all right, depending on where you want to start. If you start here, it will be sine shifted 8 units to the right. Here it's 20 units to the right, but it's negative sine. So you could actually come out with 4 equations here if we wanted. Okay, so that should get you through the rest of your homework for 6-1, which I will check on Wednesday, and it should also be sufficient enough for you to do the lesson activities that we have for today. Okay. And if you finish the lesson activities, you can start, oh no, you can't. You could do the preview exercises, and you'll have that all set for Wednesday as well. Okay. All right, let me shut off this recording.